I'm Diana Schwartz-Francisco, Assistant Instructional Professor in the Center for Latin American Studies and History. It's my pleasure to welcome you all to our 5th presentation of the GIS in Latin America webinar series, organized by the Center for Latin American Studies, or CLAS, and sponsored by the Lichtstern Fund of the Department of Anthropology here at the University of Chicago. Now, I'm delighted to introduce our speakers for today. Dr. Israel Garcia Solares is currently a lecturer in the Graduate School of Economics at the National Autonomous University of Mexico, or UNAM. His collaborator, Dr. Ted Beatty, is professor of history at the University of Notre Dame. Their talk today, Blueprint for Modernity, the Globalization of Engineering, draws from their project of the same name, which is a transnational collaborative research endeavor on the global presence and impacts of mining and metallurgical engineers between 1870 and 1930. Please join me in welcoming Israel and Ted.
All right, thank you very much, Diana. Thank you to CLAS for inviting us and giving us the opportunity to talk about our project. I'm Ted Beatty, and Israel is here with me, not here, but online with me. And we're glad to talk to you, spend the next half hour or so talking about our project. We want to talk about the research we're doing, but also the larger project that it's embedded in. And 2 caveats, or maybe apologies to begin with. This webinar series is titled GIS in Latin America, I believe. This project is not exactly a project on Latin America. It's really a global history, or an attempt at a global history. Includes Latin America, certainly, but strictly speaking is not a project on Latin America. So apologies for that, but we're glad to think about the Latin American context, which is significant. And secondly, it's not exactly a GIS project. It's a data-heavy project, a project of data science, as you'll see, and one that includes a fair amount of mapping of various kinds, but strictly speaking is not GIS. So apologies for those two issues, but I think you may be interested nonetheless, and we'll walk through the scale and scope of this project, and glad to entertain questions. So this project, which is, as Diana introduced, a history of, looking towards a history of global engineering in this 1870-1940 period, the periodization here is driven by really 2 factors. One, this is typically seen 1870 up until World War I or the Great Depression as the first massive era of globalization, the globalization of trade and goods, movement of people, movement of capital, movement of technology, and movement of ideas on a globally integrated scale. And so we want to think about the contribution of engineering to the history of globalization. It's also, as it happens, not coincidentally, the first 50 years of the history of modern engineering as a profession. There weren't, formally speaking, or in an extensive sense, an engineering profession before about 1870. And it was only thereafter that engineering schools, curricula, degrees, professional associations, the whole apparatus of a modern profession developed between 1870 and 1910 or so. And so that's the second thing we want to look at. Israel, if you want to advance to the next slide. This project really came out of both of our previous work. Israel, do you want to say something about it?
Yeah. So hi everyone, thank you for the invitation. And we proposed the session, but thank you for having us. I'm Israel Solares. I'm a lecturer at the grad school in the Faculty of Economics at UNAM. And I was finishing my dissertation, and I started stay at Notre Dame, sponsored by TED. And so my dissertation dealt with a single firm, the United States Smelting Refining Mining Company, short US company. And I was struck by the technical aspect of the administration of the firm. Most of the managers were mining engineers. And I was interested on how they, how the circulation of these technicians inside the firm, which meant outside the United States into Mexico, Honduras, Alaska, and so on. So it was this project that I started to be in contact with Ted, and we were in contact also because of his work, specifically in cyanidation on his book. So you wanna tell a little bit more about that?
Just briefly, my previous book looked at the history of technology in Mexico, and part of that looked at the role of engineers, but I did not sort of examine engineers or engineering in any systematic sense. Perhaps move to the next slide, Israel. And really, this project began with an observation that we discussed in common when we were both here together about 2 years ago. And that's that during this critical transformational period in world history, each of us individually in our own previous research were seeing engineers everywhere, literally in every corner of the archive, and signs beyond our own research as well. These are recognized globally. Engineers were everywhere, not just mining and metallurgical engineers, civil engineers, mechanical engineers, chemical engineers, electrical engineers, etc. But we had difficulty finding literature on them, scholarly literature on how to think about them, how to understand the role that they're playing, how to interpret the role that they're playing as engineers are present around the world. So we have this social group, technically trained, newly technically trained in schools of engineering during this period, that are literally engineering and building the modern world in all its aspects, yet they remain relatively invisible in the historiography. So this is what we wanted to address, a range of questions about what role are they playing, who are they, what are they doing? And we really begin this with a look at engineers who are being trained and produced, so to speak, in the United States and Western Europe. But we want to think about this also as the development of engineering as a profession in other parts of the world as well, in places like Mexico or Chile or Argentina or Brazil, but also India and China and Japan and beyond. So a true global history would encompass all of this. We began a year and a half or so ago by beginning to put together a database, extracting information as much as we could from every digitized data source we could find. We really look at three kinds of evidence. The first, and so this is a brief description of the kinds of evidence that go into the database. First, we identified about a dozen different schools that are producing mining and metallurgical engineers during this period. I should make the side comment that our case study is mining and metallurgical engineers. It's the sector, the economic sector that we knew best from our previous work. But we do want to think about this not simply as a project on mining and metallurgy, but really as a project on engineers more broadly, and think about engineering talent, that is technical expertise that's being produced in a formal way in unprecedented quantities, let's say, in this period, and what the implications of that are for economic activity, but also social exchange around the world during this period. So one source we drew on was alumni records from about a dozen different schools, including about 10 schools or so in the United States, the biggest mining and metallurgical school in Germany, the Royal School of Engineers in London, and listings of new graduates in mining and metallurgy in France as well. So we have Western Europe and the United States. The second, and Mexico. We also exactly have graduates from the National Engineering School in Mexico. The second source are members in the main professional association, the American Institute of Mining Engineers, which really was the first, I guess the second of the big engineering professional associations in the United States to be established. And we have their membership records for most of our period. And the third source are corporate directories, repeated publications of corporate directories in the United States, published in Denver and Chicago, and corporate directories published this one as this one in London during our period. And these directories list mining and metallurgical firms, list details about the firms, including the management and some of the technical personnel of those firms. Do you want to talk, Israel, about the
the project actually started really it was a small idea that we thought we could solve in a couple of months. We found these engineers everywhere, but we didn't know. I mean, the literature of mining engineering was very scarce. It's very limited, and so we started really with the American Institute of Mining Engineers. We knew they published lists of their members. I just wanted to make a survey out of that, but then we kept adding new sources during the summer of 2019, I guess. And we have been involved in this basically full time since last summer, this project of extracting this data out. Now, the way we extract this is through basically the OCR that's already provided in these sources that we find mostly on HathiTrust. And it has several limitations, and it's none of us, we're not GIS experts, but we're not data scientists, none of us. So it was really an approximation little by little to the information that we could extract from these sources that are usually non-explored. So there is basically 7 phases of the technical aspect of how we work with the database. So first we download the sources, and they usually have an OCR. There are several OCR options, but my experience or our experience, the easiest for us was just to use the one that is already provided on the text recognition but HathiTrust itself. Then we begin a process of cleaning. Anyone that has worked with OCR knows how disorganized and messy the information is once you extract it like that. Then you have to classify it, and we use regular expressions. I am familiar, I work, I am the one doing most of the work on database. On the technical side, we have now a couple of research assistants, but yeah, basically it's on R. There are other options, but that we're not familiar with because as I said, we're not experts. But so we use regular expressions on R, which basically captures information after certain words. So let's say if there is in a firm, it says located in, we teach the computer, we say to the computer, extract everything that it's after locating in, and we can extract then the location, names of people, capital. Depends obviously on the kind of source. Then we have to clean again a little bit. And after a lot of work, it's still not accurate. So we make like a randomized sample of the sources, and we evaluate with a human research assistant, or we look at what's the difference between the information we extracted and the original source. If it's, there is a mistake, what kind of mistake it is. And we basically were shooting for getting a generalized 90% accuracy on the data we get from the sources. And then the most traditional operations that are analyzing and visualizing the data. We can even add an eighth one that we haven't done so far, but it's on the horizon, which is sharing widely, which is on the project to build a website to share all this information with the public and specialists. So a little bit what have been the results? You want to talk a little bit about it?
Just briefly here, we begin to simply quantify. The first challenge is simply quantifying the production of engineering talent in Western Europe and the United States. And again, we can do that with our sources from graduates, university graduates, which we have visualized here, or association memberships. We can also use census data. So we use several different sources to sort of triangulate and get some estimates and fairly good estimates on the sheer numbers of engineers who are being produced in the US and Western Europe, which on one hand sounds fairly straightforward. On the other hand, there's been nothing written about. So we're trying to establish the baseline for the presence, the production of engineers in the world, and then secondly, that we'll talk more about here in the next slides, the mobility, their mobility around the world, because we're looking here at just our initial sample are engineers produced in universities in the United States and Western Europe. The second question is, where are they going? Where are they working? And we can show you some of the mapping we've done with that now.
So this is a little map of the different minerals located. Let's say we're focusing on Latin America, and that's both we're coming from that a little bit, this transnational interaction, especially Mexico and the US, but also Latin America and the US continental one. But if we just look at the different minerals that are produced in, or we find in our database that are on Latin America, well, we have basically our common or something that is known. We have some mineralized parts in Mexico, especially Chile, parts of Peru and Brazil and so on, and we can locate what kind of mineral they're extracting: oil, coal, silver, and so on. If we add the engineers to this map, so we now have a more, this is a map of the engineers that were at some point in their careers in Latin America. So if you look at them, well, still they're very present in Latin America, but you zoom out and you see the origin or the other places that they were besides Latin America, which is not only the States or England, or even Western Europe, but you find a circulation or a shared exchange of engineers that were in Australia, in Africa, in Asia, India, in the Caribbean, that were being shaped globally. So this is a little bit our idea, our contribution to find these transnational paths of engineers that are impacted, let's say, north to south, but also this circulation of knowledge or power and technocracy, south to south, mediated by the North Atlantic. If we look at how they move, these individuals, then you have a more complex tissue, a more complex network of engineers that are moving, yes, from, let's say, this is only the engineers that spend some time of their careers in Latin America. So yes, in Latin America, moving to this Boston, especially New York, California, Germany, but also even lateral movement directly from Bolivia to South Africa or to Australia and Russia and so on. So if you go a little bit further, the whole database, all the engineers that were not only in Latin America, but in general, it takes a little bit for the computer, I'm sorry, but then you have a generalized view of this network, of this world that's being mapped by engineers, like how their planification, their planning endeavors, their technical endeavors shaped the construction of nations, of colonies, of empires, of firms across the world. And this is, yeah, I mean, minerals produced. You can add more layers to this. So I'm gonna go back to the presentation. So yeah, if you turn off the light, this is just the points that we're mapping on the database. If you turn off the light, then you see the world. This is just the mining engineers that we have on our database, how they're literally delineating these interactions, even with we know it's not, it's very Western centric, the database, but this is part of a global story. That's basically it.
Yeah, good. So when we said in the archives, we had seen engineers everywhere, literally. At that point, I guess we were saying we saw them everywhere figuratively. Here we begin to see them literally in every corner of the world, and this sort of deepens our motivation to continue thinking about how to interpret this. I mean, this is sort of this first phase that is primarily what we've worked through up till now, is counting the production of engineers and mapping their global presence. The next phase will be to think more analytically, more interpretively about how do we interpret this? How do we want to think about the role of engineers in processes of globalization? How can we balance our database, which is primarily, as Israel said, Western-centric, production of engineers in the US and in Western Europe? How can we balance that with the production of engineers and look at the interaction between engineering expertise from the North Atlantic and engineering expertise that begins to appear from engineering schools in places like Mexico, Chile, Argentina, India, China, Japan, et cetera, around the world between 1890 or so and 1930, 1940. So very quickly, countries around the world developed their own capacity to train and produce engineers. And we're very interested in this interaction that we had not been able to look at yet. So the broader project then has several goals. Our research, really, as we think about it right now, so we're thinking along four streams. One is this, what we primarily talked about today, that is the globalization of modern engineering, technical expertise more broadly. What does that global presence look like, and how should we interpret it? That's one focus. Secondly, very much relatedly, what is engineers' role in management? That is, to what extent are engineers on one hand filling roles as technical experts versus on the other hand, or playing roles as managers, planners, designers within corporations and government agencies. So that the role in management, we recently presented an early paper on that and need to think more about that. Third, the role of engineers in this global network and technical innovation. What role are engineers playing in technology transfer and innovation in these global settings? And finally, what does this global network look like? Is it a network or a set of networks that are bounded by organizations, by firms, governments, nationalities, et cetera? Or is it a network that's very porous, where information is shared amongst engineers across the boundaries, across organizational boundaries of firms and national associations and government agencies, et cetera? So those are sort of four big themes that we want to wrestle with over the next year or so. We're also working with a group of colleagues on sort of thinking about this also as a collaborative project. And we have a great group of colleagues who are also working on engineering or related topics of technical expertise in various parts of the world. We've hosted one workshop already on that. And we'll be hosting another towards the end of this year to help to think together about how each of our case studies and approaches can contribute to a global history of engineering. We've developed an undergraduate course. We'll say more about that in a minute, and looking forward to developing a website on this. So the collaborations, just to give you a quick sense of that. This is the group who we hosted together last year, and we will again at the end of this year as we look towards a collaborative and collected body of work that we can pull together to contribute to a global engineering history. And it's the wonderful thing about this group for us is that we come in with a database that provides a large end study portrait of engineering talent across the globe. But there are many questions, put it this way, our data in many ways raises more questions than it answers. And so localized case studies give us a way to test our data against test our database against these case studies and more qualitative evidence in the case studies. We also developed an undergraduate course. We developed an undergraduate course on this that we taught for the first time in an intensive format in January, and we'll teach it again this fall semester here at Notre Dame. And it's a course that that really tries to do three different things with a group of undergraduate students. It was very successful for us in January, so we're excited about repeating. First, it presents what I would have thought 5 years ago was about as I suppose as boring a topic as possible, the history of engineering, but puts that in the context of the rise of professions, technical expertise in the 20th century world, history of globalization, and history of capitalism. So partly it's a history of engineering in the modern world. Partly it's a data science course that's teaching students some of these tools that we're using, that Israel discussed earlier, that enable students to extract data from digitized sources, code and clean that data using computer language, and then visualize that data. So begin to analyze and think about some analytical approaches to visualizing the data, and then write a project report that contextualizes that more broadly. And this is essentially what we had students do. The third component is, how this is historical methodology, essentially. How do we want to think about the classic questions that we as historians bring to a topic, how to develop a topic, develop hypotheses and research questions focused on that topic, collect evidence, synthesize, analyze, and present. And so the course is really a project-based course in which students get a history of engineering, but then really dig into a project of their own, identify a digitized primary source, extract that information digitally into a data set, do the coding and cleaning of that data set, visualizing the data, and writing a contextual report on it. And we had the 25 students in our course this last January did a wide range of really wonderful topics on some of them who were engineering majors themselves, did topics on their own field, civil, environmental, chemical engineering, etc. Some of them chose professional associations, some of them chose particular sectors, transportation, several students doing transportation topics, railroads, tried to keep them in the 1850, 1950 era generally. At any rate, and then came up with mapping. If Israel were here with our PowerPoint, he would show you a few of the visualizations, mapping and graph visualizations that they produced. But that was exciting. It was a non-traditional course for us, and was very, very successful. So we're excited about doing that again. So to wrap up, this for us, this is a multi-year project on the history of global engineering, but wanting to use engineering and the history of production and the globalization of technical expertise more generally as a way to think about some big topics, some big questions and big issues in the history of globalization over the last 150 years, history of capitalism, and the role of technical experts in 20th century and now 21st century society. As we know, of late, there is in the US and Europe reaction against expertise, technical expertise, expertise generally, and we want to think about where the presence, the degree to which technical experts came to dominate planning, to use that as a placeholder for perhaps, in not just the technical world of production, whether that's in mining, metallurgy, manufacturing, or other fields, but also in organizational management, in government agencies, social planning, and beyond. And so there's some sort of big questions there that we hope to be able to get some purchase on, but beginning with our case study of mining and metallurgical engineering in the early 20th century.
I'm sorry.
All right. Well, I just ran through our description of the course, Israel. Do you want to perhaps show the HTML for the one student put together, and then we can, and I sort of wrapped up there as well while you were gone.
Okay. Yeah, so I'm sorry, it had never happened. It completely crashed my internet. The course, we had several levels of expertise in coding before from the different students. So I don't know if Ted showed a couple of the visualizations of the, did you?
I did not, Israel. I did not share.
Okay, so there were some students that had very high capabilities of coding or data management. So this is, for instance, the study of Bianca Bijaja about the role of engineers in World War I. And well, she was able to trace from the movement. If you see, there is actually a movement of engineers into Mexico. But just in general, since they were recruited up to the role in the war. Also, Danielle Gerardi, for instance, here, she kind of traced the percentage of patents and the relationship between the assignment of patents with the number of patentees, of patents by each patentee on 10 years. So very impressive. And so, for instance, Danielle had previous experience, like high knowledge in data science. Bianca had middle knowledge, let's say. And then, for instance, the project of Madeleine Owen that I'm going to share with you, she had no previous experience in data management at all. And she produced this map on basically the railway engineers and where they were working in different parts. This is the list of 1921. So the members of the Association of Railway Engineers in 1921, and trace the company they were working on, and basically their location and their name. You can see a lot of them in the Americas, but also non-negligible number in China and in Asia, in Burma and so on. So this is the last part of the project that we wanted to share with you. Just to wrap up this different phases from us encountering this data sources that haven't been explored, developing a way to manage them, extract some conclusions out of it, and then share a little bit the methodology and some of this. It's not a lot of technology, it's just an application of it into many unexplored sources that are around and available. And that's it. Thank you.
Great. Well, we're glad to take questions using the Q&A. I see there's one, I answered one just online, but the question there right now is how come there are only 2 universities from Europe, and whether this has to do with available sources or other options for studying engineering in the region. Good question, and this is one of the things we continue to struggle a little bit with is what is the nature of the data we have? On one hand, we do not have a random sample of data. The data we've been able to collect is really a function of what we've been able to find digitized. So that's at the first order really limits what we can do, what we can find that's already digitized. As Israel says, most of that has been through HathiTrust, some through Google, some through other sources, library and archival sources, but primarily HathiTrust. And it's also a limit that's constrained by simply the time and energy we have to devote to tracking down and scraping and cleaning digitized data. So in Europe, we have there were a number of schools that trained mining and metallurgical engineers, especially in Germany, but we focused, on the largest, historically by far the largest producer and the best known, most reputationally most important school producing mining and metallurgical engineers, the Freiburg School in Saxony, in Germany. So we focused on them, extracted. We were able to get their digitized list of alumni for really over a century and incorporated that. The Royal School of Engineers in London was not the only, but was probably the most important, at least the most prestigious. We've incorporated that. And then a list of mining and metallurgical engineers published by the French government, recent graduates there. So we, on one hand, we do not have a random sample. On the other hand, we do not have a comprehensive set of all mining and metallurgical engineers produced in the US and Western Europe. However, we have a significant majority of those, and a database that exceeds, what is real, 50,000 individuals.
50,000 individuals.
50,000 individuals. So given a database of that size with information about where they went to school, for many of them where they went to school, where their career history of employment, and some other information, and the ability to match many of them to corporate employment in specific firms, there's a lot we can do with this. But there certainly will be corners of the mining and metallurgical profession that we don't capture in this database. And that's one of the things we'll have to be very explicit about as we go on.
We actually, I mean, at some point when you deal with alumni lists, it's just as easy or as difficult to extract all of their degrees than extracting just the mining engineers. So actually we have now the database that we talked about, 50,000 more or less individuals we have across many engineering types and geology included. We have mining metallurgical engineers, we have chemical engineers that are directly related to the mining industry, but also we have electrical, civil, we have, it depends on really on the source. There's we just processed the Berkeley source, the Berkeley alumni list from like some 40 years of alumni from Berkeley, and we have even lawyers and physicians and so on. So we kind of subset only the engineers that are our interest, but we do have more like a generalized database on engineers. And also the bigger project, I mean, our research papers are on mining engineers and on the mining sector, but the larger project is on all engineers. Like all our collaborators work on agricultural engineers, I mean, agronomists and industrial engineers, mechanical, and so on.
I actually have a somewhat related question. I think it's related. When you were giving the presentation, one of the early slides showed, I think, representation over the years, right, from of your data set. And I noticed some spikes that seemed pretty marked. And I was wondering if you could talk a little bit about the spikes and kind of, I realize you're still early in the project, and so having kind of concrete conclusions may be a little bit more trying right now, but if you, I don't know, if you could sort of venture some guesses about why the spikes, or if there are other sort of pieces of evidence from the data that you've gathered so far that you think in some ways reflect other kind of historical processes or institutional processes that you know from your own research experience outside of this project.
Yeah, good. It's a great question, and as you say, it's I'll say some general things about that because I think a lot of this work still lies in front of us. But a couple comments on that, and this is maybe pertains both to the data from the alumni records, which is the one we showed earlier, but also the data from association membership and other sources as well. You know, the general trend clearly, and this goes across all engineering fields, mining and metallurgical engineer, but also mechanical, civil, electrical, chemical engineering. The general trend is one with tiny numbers, sub 50 before 1870, and then a rapid growth in numbers of engineering graduates across all fields, slightly different timing across those four major fields, but rapid growth through the 70s, 80s, and 90s to the turn of the century and a little bit beyond, really up till about 1910. So there's rapid growth in the production of engineering talent. It's mostly driven by the United States, which is very quickly exceeds Europe in the production of degreed, that is fully degreed engineers. It begins to take off with in the aftermath of the Morrow Land Grant Act in 1862, and the creation of technically oriented, practically oriented universities in the US, which begin to create engineering schools. So those begin to come online by the early 1870s, and then numbers of these programs, engineering programs, expand rapidly through the next 30, 40 years until by 1910, really up till about World War I, those programs had reached a mature, steady state and still grow in size, of course, into the early mid 20th century. But that rapid escalation is one thing we see clearly. There's some jumping around in there, which we haven't explained some fully in our data. You can see the impact of short-term economic factors, the recession of 1893-94, the economic crisis of 1907-1908, which both of which are felt globally, but particularly in the United States, and those have an impact, although we haven't looked at that systematically. World War I, beginning in a European sense, 1914, and with U.S. involvement by 1917, also has an impact. World War I draws a lot of attention to engineering and the critical role of engineering in from a national defense perspective. And in the military, a lot of engineers are drawn out of mining, metallurgical, civil, mechanical engineering and pulled into the European conflict in 1917, 1918. We had one of our students do a project on that. These historical moments have an impact on production and work experience of engineers across engineering fields. But specifically, Diana, to your question, the two issues that are, we haven't sort of systematically examined the impact of those historical moments. And secondly, there may be some source related issues with Israel. I don't know if you want to say anything about that.
Yeah, I mean, there is some sources that we have just for a couple of years or 3 years or 4. So it's there is a relatively limited, but also the most, let's say, important or bigger schools in engineering. We have a longer and more stable database on them. So MIT, Colorado School of Mines, Columbia, Berkeley, and so on. So we have Freiburg, Royal School of Mines. So like for instance, we didn't include in those graphs the Escuela Nacional de Ingenieros, but if we had put that, it will have a lot of spikes because we just have some years for that. So yeah, there is a like a random error to that. We're trying to reduce that and to limit it in our observations. Another thing that I kind of wanted to say regarding to that, there is in global history, in economic history, there is always this talk about exogenous technological shocks or technology as something exogenous to the system. So also part of the mission of the project is to explain these shocks or these changes in technology and in technocracy in general. And it's just something that we mention every time we present the project, but it's just because it's interesting. This growth of engineers had consequences beyond the economic system and so on. Like in 1930, there is this particular point in time where the leaders of Mexico, the United States, Canada, and Britain, they're all mining engineers or worked in the mining technology business. So from Hoover to Pascual Ortiz Rubio, and so these 4 leaders at the same time, they all came from this growth of mining engineers in a specific. So so this is like a different kind of technology shock that we wanted to include in the larger narrative of the globalization and the creation of these nation states, modern nation states and empires and so on. I think there's another question.
Yeah, there's a question there on if we thought about pushing our research back into the mid-19th century or earlier, because of the importance of knowledge, scientific knowledge in particular, on state building in Latin America in the early Republican period. And it's a great question, and it's one actually we're intrigued by. The connection we have to it perhaps is through Alexander von Humboldt and his work in Mexico and his publications in Mexico in the very early 19th century, just before independence, which had such a big impact on many of the independence era leaders, but on intellectual conceptions of Mexico as a nation over those first decades of national independence. And there's the story there is really more science than engineering. As we said, really our early bound of our project is the development of engineering as a modern profession, which is about 1870. But we're very conscious of engineers, Mexico as the location of the first higher institution is focused on technical issues, the mining college, the Royal Mining College in Mexico City in about 1790. but the role of science and technical expertise preceding our era. We probably won't extend our work back to that, but we want to think about that contextually. So thanks. It's a great question, and it's part of that longer history, or the history of the long 19th century in Latin America. Critical. Israel.
Yeah, and that history is pre-national, not only on Latin America, but also in Europe. We're just analyzing the Freiburg list that we have. And I mean, at the beginning, they were around Saxony, the people coming to Freiburg School of Mines. Humboldt was coming from Prussia, so there was some nation building through a transnational network of engineers. Like not only Humboldt was vital on the sort of the imaginary, at least, of what would be a Mexican Republic, but these engineers coming back and forth to Germany were also extending the boundaries of the small semi-states or royal states in Germany until they considered until the late 19th century. So yeah, we just want to play a little bit about that on that, but yeah, our focus is on the 1870s to 1940s, more or less.
If I can step in and ask another question, it actually has to do to a certain extent with kind of the notion of spatial rendering or spatial representation, and a question that you all posed early on about South-South relations. So there were a couple of nodes on the map that I noticed were kind of literally in the Southern Hemisphere, right? I think many of them were coming from what looked like Chile, or perhaps that part of kind of the Southern Con, maybe even Bolivia, I'm not remembering well. And to, I think I saw one connection to somewhere in South Asia, maybe India. So I'm curious about this. This is, as you know, kind of a growing sort of concern for a lot of global historians, but especially those historians who are interested in Latin America and the world and thinking about Latin America beyond kind of relating to the North Atlantic world. There's the sort of Latin American and Pacific idea, but then there's also this kind of question about, I mean, obviously it's not considered South-South in that moment, right? We don't have this notion of the global South in the late 19th, early 20th century, but this notion of expertise moving prhaps, yes, in these geographies of technology and power in the North Atlantic, but also in technologies, or sorry, geographies that aren't necessarily the canonical technologies of power sites, right? So I'm curious, and I guess kind of both about that representation. Like, are these just a couple of folks that you see in your data that are moving in these South-South spheres, or is it more than just a couple? And like, what about those geographies is interesting to you?
Israel, do you want me to jump in? Or do
yeah,
you
yeah, it's I think I mean this relationship that we're mapping, it's mediated through the North. Like it's because it's our sources are from the North. North Atlantic. So even if it's, let's say, the American Institute of Engineers, someone that was moving from Venezuela to South Africa, just moved the address to South Africa or to Bolivia or to Mexico. So, but it is at the same time part of that Western North Atlantic network. But we do find, like as Ted said, we're trying to kind of build a framework to these studies. And we know a couple of cases, for instance, the Jennings family, actually 3 of the persons on our network, it's Mark Hendrickson, Doug Jones, and we find information about the Jennings, which were 2 mining engineers that were brothers, and that one started in Venezuela, moved to California, went to South Africa, and was part of this racialized work experience, and then moved back to the States. And then the brother moved to Mexico, and then was having projects in Venezuela. And well, he also worked a little bit in South Africa. So these connections of individuals not only link technologies of extraction, but also organizations, methods of organization of labor. And there is a South-South connection that is mediated through these organizations, individuals, empires from the North. But they do build a common or history that actually starts in Venezuela. It doesn't start in California, and it's in South Africa, and then comes back to Venezuela. So that's just one example, but that's a little how these connections work and build geographies that are, as you say, they're not used to it, and even the idea of the spaces of empire, of the spaces of corporations change once you look at it globally.
And another way to think about the same, your question, Diana, is this is an aspect we cannot capture. We want to, as Israel said, we need to recognize first and foremost that our data is from a particular vantage point, that is expertise produced in the US and Western Europe. So that begs two questions. One is, what language, what words, what verbs should we use to describe the mobility of North Atlantic trained engineers around the world? Israel and I were just discussing this morning. Is this a process of diffusion? Is it a process of circulation? Is it, what are the, quite literally, what are the verbs we want to use to describe what we see? The kind of movements that Israel just alluded to and that we can capture in some of our mapping. We still need to wrestle that out, and it's going to be a critical piece. Secondly, what we do not capture in our database, but which many of our collaborators do, is what is the relationships with engineers who are being trained in Latin America or Africa or China or other parts of the world, or who are coming from other parts of the world to Europe or the United States for training and going back to work or moving. We have one colleague who has two Chinese engineers trained in China initially, doing a little studying in Europe, joining the American Associate, coming to the meetings, annual meetings of the American Mining Association to present papers, part of a global network of some kind, but in the other direction. And how does that shape how we want to think about this global presence and network? Similarly in Chile, similarly in Mexico, with these kinds of interactions in universities, in firms, in professional associations, and on the shop floor, so to speak, or at the rock face, so to speak, in work sites. So there's a lot we've still got to work through to address that question, Diana, but that's going to be central for us in one way or another.
All right. Well, thank you both, Israel and Ted, for introducing your project to us and for the stimulating conversation about the possibilities. Really excited to hear more about how it goes moving forward. And I really appreciate you sharing the pedagogical side of it with us as well. It's something that many of us here at UChicago are trying to develop too. So we will be in touch. And thank you to, of course, to our interpreter, Silvia Escarcega, for offering this opportunity for our colleagues to listen in Spanish. To our attendees, thanks again. And we look forward to seeing you at the next one.